Start. Now we are going to start the chapter 1 of the paper 1. You can see there first chapter of the paper 1, unit 1 is the Newton law of motion. As you are already aware about this Newton laws of motion, we will directly move towards the first law of motion. The first law is deal with the inertial frame of reference, or say inertial reference frame, that states that Newton's first law states that a body at a rest, a body at a rest will remain at a rest if it is in motion. It will continue its motion in the same direction until and unless an external unbalanced force is applied on it. That is a very much important thing. First law is that if the any object is having is there in any condition, that will be as in their own state. A simple example is there. If we are there, if you are stand at one place, then we will become in the only one position. If any force is applied on us, then we will just change our position. What we'll do? We will change our position. That is the first law, deals with this particular that thing. MCQ will be there. Newton law, first law deals with the dot inertial reference frame. Means whatever their frame is there, whatever their position is there, with respect to, with reference to that, that will be there. That Newton first law says. That says that if any object that is in the rest position or the motion, it will be in the same state unless and until there will be an external unbalanced force is applied to it. Okay, very simple thing it is. Then if sum of all the forces acting on the body is F bar and its acceleration is A bar, then according to the first law of motion, F bar is equal to 0 if A bar is equal to 0. If you can see here, if double if and only if A bar is approximately equal to 0, or A bar is equal to 0 if and only if F bar is equal to 0. That is the first law of Newton first law of motion. Then you can see there the first law states that body which remains at a rest or in uniform motion, that is the unaccelerated rectilinear motion, has zero force. The first law also implies that all the bodies that resist being accelerated, the property of the body is by virtue of which they always oppose the change in the own state is known as inertia. Hence the first law of motion is known as law of inertia. Body can be in the position of rest or motion, so the inertia of body are of two types, namely inertia of the rest and inertia of the motion. That may come for the MCQ purpose. The property of the body by virtue of which they always oppose the change in its own state is known as dot. First law provides a qualitative definition of the force and recognizes inertia as a fundamental property of the material bodies. Then Newton's second law of motion. Newton's second law states that the rate of change of momentum of a body is proportional to the force applied and direction and the direction of the change of momentum is the same in which the force is applied. If the velocity is a v bar of the body having the mass m, then the momentum of the body is given by, mass into velocity. Momentum is p bar is equal to m into v bar. Let f be the vector sum up all the forces acting upon the body at any instant of time. Then f bar is given by dp bar by dt. F bar is equal to k into dp bar dt, where k is the proportionality constant. F bar is equal to k into d by dt mv bar. For non-relative velocities, v bar greater than the c bar, where c is the speed of light. V bar is less than c bar, where the c is the speed of light. The mass m of the body can be taken as a constant. Therefore, F bar is equal to k into m dv bar by dt. dv by dt is nothing but acceleration. Rate of change of velocity with respect to time is nothing but the acceleration. That may come for the MCQ. The rate of change of velocity with respect to time is called as the acceleration. That you have to remember. Therefore, in short, you will get F is equal to kma bar. In the SI unit, if m is the 1 kilogram, a bar is equal to 1 meter per second square, and F bar is equal to 1 Newton, then K is equal to 1. Hence, F bar is equal to ma bar. Therefore, force is equal to mass into acceleration. The second law provides the quantitative definition of the force. First was the qualitative definition of the force, and here second law gives the that particular quantitative definition of the force. For Newton's first law of motion is concerned with the bodies at rest or in uniform motion when no forces are acting on it. The second law assumes that the force is acting. The law describes how the motion changes. And the last law, the Newton's third law of motion, Newton's third law states that to every action there is always an equal and opposite reaction. Simple example you can remember. If anybody doing anything, let's say you can see every action there is always an equal and opposite reaction. uh, if anybody slapping you, then what is your reaction? You will again slap your friend. If your friend is slapping you, then immediately you can slap to your friend. That is every action has equal and opposite reaction. The action of an one object is equal to the reaction of other, but in opposite direction. If the first object applies force F2 on the second object, then F12 bar will be force of the reaction of the second object on the first. F12 bar is equal to minus F21, or F21 bar is equal to minus F12. These forces always exist in the pair and do not cancel each other. This is about the Newton laws of motion. There will be the MCQs based on their statement. There, what is the first law gives? It provides the qualitative information about the force, and here in the second law provides the qualitative or quantitative information, or say definition of the force. Okay, inertia, then Newton's first law, second law, third law. That may be for the MCQ purpose. Please go through these things. If you are not getting anything, you can ask. Okay, here we will stop, and the next part we will continue in the next lecture. Thank you.